Hello, this movie is for points, lines, and planes in our first unit. Point, a line has two arrows, goes on forever, and a plane is a flat surface. So we know of a coordinate plane where we look at the x and y axis. That represents a flat surface. Geometry is a mathematical system built on accepted facts, basic terms, and definitions. Undefined terms, terms that we can't define, they're so basic, are points, lines, and planes. A point indicates a location, but has no size. So you can represent a point by a dot and name it with a capital letter. So we call that point A. We could have point B. Point. A point is in zero direction. So we're looking at 0 dimensions for a point. A line represented by a straight path that extends in two opposite directions without end has no thickness. So even though we can see this, we can see that there's thickness. In reality, mathematically, a line does not have thickness. Now, a line continues forever in both directions, here and here. And this right here is supposed to be a cursive L. We could call that line L. We could call that line XY. We could call that line YX. But notice that you have to have the line symbol above it to represent line XY. So you name a line by any 2 points on the line. You could have multiple points. You could have 10 points on this line, but you only need 2 points to name the line. And a line, I should say, has one direction. It's a 1D. Very good band. Too bad they're not together. But it is definitely a one direction thing. A plane is 2 dimensions. So we have the 1 dimension and the 2 dimensions. Plane is represented by a flat surface that extends without end, has no thickness. So a plane contains infinitely many lines. So you can see if I connect A to C here, I've got a line. B to C here, I've got a line. So on and so forth. But just like when you're playing soccer and the ball has to break the plane of the goal, that's what a plane is. It's a 2D surface. Now, mathematically, it goes on forever without end. But in this case, we tried to represent that plane here. Walls of our school represent planes. Now, notice how you name a plane. Capital letters, and this could be a plane P, usually cursive, or you name at least 3 points in the plane that do not all lie in the same line. If they lie in the same line, we call those points collinear. And those points would not represent a plane because I could put infinitely many planes through that line. But if the 3 points are non-collinear, like ABC here, there's no way to put one line through these 3 points. I could do several lines, but it doesn't represent one line. Therefore, those 3 points, because they're non-collinear, are representing the plane. So we call this plane A, B, C. Notice they're all 3 capitals. There's no notation above it. That's how you name a plane. So let's go to some examples here. Name one line 2 different ways. So we can see we've got a line here. We've got 2 planes intersecting, but I'm going to use that line. That line we're going to call line CD. We could also call it line DE. We could also call it line L. This is supposed to be a cursive L. We could call it line CE. And then the reverse, line EC also works, things like that. Name a plane 2 different ways. Well, we've got 2 planes here. And this red plane right here Let's look at that. We've got points in that red plane. I've got F, D, A, B, G are all in that plane. So if I want to name that red plane two different ways, I could call it F, A, G, no, B, FAB, because those are three non-collinear points. I could also name that plane DAG, because those are three non-collinear points also in that plane. One thing you cannot do is name it BDA, because those 3 points are collinear. They're in the same line, and therefore you can't name a plane with those. There's also a cursive R, so I could call it R. I could call it capital BFD, and those are three non-collinear points. Now I could also name the blue plane here. That blue plane could be CAE. Those are three non-collinear points on that plane. We could call it BAC. We could call it plane P. And as long as you're using three capital letters that are non-collinear in that plane, you're good. And then name 3 points. Point C, point B, point F. And notice I put commas in between, because if I didn't, it would look like I'm naming a plane, because I would have 3 capital letters next to each other. So terms that are defined, we have space, which is the set of all points in 3 dimensions. We have segments, part of a line that consists of 2 endpoints and all the points in between. We know line segment AB. Array, part of a line that consists of 1 endpoint and all the points of the line going in one direction. Good band. One direction. So that would be ray AB. And notice how you label that ray AB. The end point must be above the A, the arrow part above the B, because A is your starting point, B is denoting the direction you're going. I could also have ray AC, where I'm starting at A again, but now I'm going in the direction of C. So those are 2 rays. I could have ray AD, and that would be starting at A, but going in the direction of D. 2 rays that share the same endpoint and form a line are called opposite rays. So if I've got this ray, let's do this. I'm going to do a line, but I'm going to put 3 points on it. I want you to see that ray YZ has an opposite ray, which is ray YX. Because they both have the starting point at Y, but they're extending in opposite directions. So we say that these 2 rays are opposite rays. What are the names of the segments in the figure? Well, you've got segment XY, segment YZ, whoops, and segment XZ. What are the names of the rays? So we could start at X and go in the direction of Z. We could start at Y and go in the direction of X. We could start at Y and go in the direction of Z. We could start at Z and go in the direction of X. These are all different rays. Which of the rays in question 2 are opposite rays? So the opposite rays have the same endpoint, but they go in opposite directions. So we've got ray YZ, and we have ray YX. we're going to learn a lot of postulates or axioms. These are statements of facts. Postulate, like an undefined term, they're just basic building blocks in geometry. And you're going to learn a lot of these here. None of these need to be memorized. All of these are foundational to the things we're going to be doing. So as we go through, if you say, oh yeah, that makes sense, that's all you need to be able to do. Postulate 1.1 says through any 2 points there's exactly one line. So this is a foundational idea that we'll build on. Then we have, if 2 distinct lines intersect, they intersect at exactly 1 point. And we've done that, where we've graphed 2 lines in algebra, and we saw where the intersection of those lines would be. That's actually an example of that postulate. If 2 distinct planes intersect, then they intersect at a line. So you can see if 2 walls intersect, they're going to intersect at a line, which would be the corner of the room. Well, edge. Through any 3 non-collinear points, there's exactly 1 plane, like this. A, B, and C have 1 plane going through them. Let's look at the intersection of 2 planes. We've got plane F, E, H. If I connect F to E to H, the 4th point to finish that connection would be G, and I'd be talking about this plane up here. If I want to see where it intersects with BCG, BCG is here, it would be this. Now where they intersect is right here at GF. So it's at line GF. Let's go to here. I mean, we could name it FG as well. They're both the same. What is the intersection of ADC? So let's get some different colors here. ADC is down here, also with B. Notice there's a 4th point, but I only need 3 to name the plane, so that's why I'm not using all 4 points. And then BFE. BFE is this front panel, and then A closes that off. So we see that this front one is here, BFE. So where they intersect would be this line AB. Could you have BA? Yes. You need the line above it. So we can see where things intersect. Note, when you name a plane from a figure, you go in a direction. So, for example, now these are bad examples because we're not naming the plane. There are more than 3 letters. But if I go F, G, H, E, that's fine because I'm going in the direction of going counterclockwise. E, G, F, let's look at this. E, G, F crosses it, so you can't do that. Meaning, I can't go across. I either need to go clockwise or counterclockwise when I'm naming a plane. So, no jumping across. HGF, let's look at that. HGFE works. And GHF crosses over, so that does not work. So you just have to make sure you're going in a circle. A plane. It reminds me of the 3 points you get on a tripod and how those 3 points are sitting on a plane, the plane we call the floor. And those points can be collinear in the same line, but that would be multiple planes, coplanar in the same plane. So when you have a tripod, if those 3 points were in the same line, they would tip over. So you can't name a plane with collinear points. You need non-collinear points. Coplanar points are just points in the same plane. All right, pause the movie, try this guy on your own, and then press play when you've finished. What plane contains the points HFB? HFB is here. Well, look at that. That is this guy. So it reminds me of those famous popcorn places where they put that divider going through the box. And that one is doing the same. What is the name of the line that is coplanar with FB? Let's see, FB is here. And EF is here. And you can see that the point is point F. Where they intersect, what is the name of a line that is coplanar with FB and EF? Coplanar is on the same plane, in the same plane. So, naming of a line, we could put other lines like AE is in that plane. We've also got AB is in that plane because they're all in that front plane here. And that is all for this lesson. I apologize for my voice. I'm trying. And I will be back to answer questions hopefully soon.